Let's do a unique example for finding the composition of two functions where the function values are given in a table instead of in a graph or with an expression for each function. So I'm not going to do all 6 of these. I think I'd like to do, how about A and D, and I think at least maybe E. Let's do those. So we'll do those 3. So starting with A, we're finding f of g of 1. Now remember, what this means is we're finding f evaluated at, I'm going to change colors here, g of 1. So we need to figure out first, what is g of 1? Okay, well that's pretty easy. That means on the g of x part of the table where we find the g of x values, we need to figure out g of 1. So when x equals 1, what is the function value at g for g? So here are the x values. So when x equals 1, g is 0. So g of 1 is 0. So that tells us here we have f of 0. Okay, now we're going to sort of start over again and look at the table for the f values, the f outputs, f of 0. Okay, so let me get rid of this so it doesn't confuse me. So, okay, this means when x equals 0, what is f of x? Okay, so here's the x values. So x equals 0, x equals 0, f of x, that's the second row, is 4. Cool, okay, so here's what we do. We take the x value that's given here in the original question, f of g of 1, and I plug x equals 1 into g. X equals 1 for g gives an output of 0. And then I take that output, 0, and plug it into f. So take x equals 1 and figure out what the g of 1 is, and then take that result and plug that into f and figure out what the output is there. Let's try that again. Let's try that with a different example. Let's do D. So D is, what is g of f of 3? Okay, so that means what is g evaluated at f of 3? Okay, so we need to figure out f of 3. So let me erase my work from the previous example, if it will let me. Doesn't want to let me. There we go. There we go. Okay, f of 3. So I need to find x equals 3. X equals 3. Oops. And then at x equals 3, what is the f value? F is negative 2. So at x equals 3, f of 3 is negative 2. F of 3 is negative 2. Okay, so that means this is actually asking us to find g evaluated at f of 3 is negative 2. So that's actually asking us to find g evaluated at negative 2. So now this is the input we're going to put into g. So let's see, x is negative 2 is here. And the g value, oh, that's strange, is actually negative 2. So when x is negative 2, the g value happens to be negative 2. So g evaluated at negative 2 is negative 2. Okay, let's try at least one more. All right, there we go. We'll do E. G of g equals 1. Okay, so this is the x value. That 1 is the x value, and we want to find g evaluated at the output for g of 1. Okay, so let's figure out what g of 1 is. So going along where the x values, x equals 1, g of 1 is 0. So let's look at that. X equals 1, the g value of 0 is 0. So since g of 1 is 0, that tells us that the inside here, the input, should be g of 0 now. Okay, so then this red 0 is our new input. So now we go back over to find x equals 0. Oops, I want a different color there. There we go. So g of 0 is 2. Great. So just to be clear, here's what we're doing. We're taking the value here for x, plugging x equals whatever the given value is into the first function next to it, the function on the right. Figuring out that value, g of 1 in this case, and taking that output, g of 1, which happened to be 0, and plugging that into the next function, the function on the left, and figuring out what that output is. So when x equals 1, g of 1 is 0. When x equals 0, g of 0 is 2.